Here are the solutions for Day 2, Problem 1. There's two parts. Part A, identify the slope and y-intercept for the graph of y equals negative 5x plus 2. And then in Part B, we're going to graph the equation on the grid. So we're going to draw the visual representation of this equation, which is going to be a line drawn on that grid. So let's tackle Part A first. It first asks us to find the slope. Another vocabulary word that means the same thing as slope is rate of change. We're asked to find the rate of change in this equation. That is, how is the value of y changing as the value of x changes? And one way to find the rate of change is to find some values of x and y. And once we know those numbers, we can simply look at them and see how are they changing. And so let's find some values. When x is 0, what would the letter y equal? Let's find out. And so y equals negative 5, and let's substitute in 0 for x, and then plus 2. Negative 5 times 0 is 0, plus 2 is 2. And what we figured out is that the value of y is 2 when the value of x is 0. Let's find another value of y. What if we change x from 0 and increase it by 1 unit so that x is 1? What will happen to y when we do that? Let's find out. Y equals negative 5. Okay, we're going to change the value of x. Instead of 0, let's put 1 in this time. And then plus 2. What does this equal? Negative 5 times 1 is negative 5. And negative 5 add 2 is negative 3. And so we found out that y is equal to negative 3 when x is equal to 1. Okay. So how did these change, though? When we changed the value of x by 1 unit from a 0 to a 1, when we increased the value of x by 1 unit, what happened to the value of y? Well, it changed from a 2 to a negative 3. It has decreased by 5 units. So when x increased by 1 unit from 0 to 1, the value of y decreased by 5 units. It changed from a positive 2 to a negative 3. We can write that as a rate, right, by putting one of the numbers on top of the other like a fraction. And that rate is called our slope. And so what we found out is that y decreased by 5, that's a negative 5, when the value of x increased by 1. That'd be written like as a positive 1. And so we have negative 5 over positive 1. That's called a rate. Now this rate does simplify to just the whole number, negative 5. And so we found that our slope is negative 5. It not only refers to how the line is sloped when you draw it, but it refers to the rate of change. How is the value of y changing when the value of x is changed in the equation? Okay. Now in Part B, or not Part B, but just the other thing that we were asked in Part A, we were asked, what is the y-intercept? So let's find that. The y-intercept. Well, to do this, we need to think about what y-intercept means. On a grid, the y-intercept of a line that you draw on the grid is the dot on the y-axis. Here's the y-axis running up and down. It's the dot on the y-axis where the line passes through. And so if you drew a line and it crossed right there, then its y-intercept would be 5. If there was a line drawn on a grid and it happened to cross the y-axis right here, then its y-intercept is 1. So the y-intercept is wherever a line is crossing the y-axis. Now the key thing to realize here is that any dot that's on the y-axis, whether it's this one, or this dot, or this dot, or this dot, any dot on this y-axis line will have an x-coordinate of 0, because for the dot to be on this line, then when you find that dot, you don't move to the right or to the left at all on the x-axis. You stay at 0 on the x-axis and then go up or down to get to that y-intercept dot. So the value of x for the y-intercepts is always 0, and we can make use of that fact to find y-intercepts. In this question, we actually already have done all the work we need to find the y-intercept. This very first work step we did, we put in 0 for x, and that is how you find the y-intercept. You put in 0 for x and then figure out what does y equal when x is 0. And when we did that, we found y was 2. So the y-intercept is 2. As an ordered pair, you could write it like this: 0, 2. When x is 0, y is 2. Now we can do part B. Graph the equation. We can graph a picture of this equation by using these values that we figured out in part A. One of them was called slope and the other was called y-intercept. If we use these two values, we can find the line. Let's start with the y-intercept, because the y-intercept is a dot that we know is on the line. It is at 0, 2. Let's find that dot. Start at the origin. Don't go right or left at all, and then go up to the 2. 1, 2. Here is a dot. This dot's called the y-intercept dot. To get another dot on the line, and then we can draw the line through the dots, we're going to use the slope, or the rate of change. Remember, we found that this was -5. Let's think about what that -5 meant. The value of y is decreasing 5 units when the value of x increased by 1 unit. And we can make use of this to get another dot. Let's do that. Start here. Okay. Remember what this said again? When the value of x increases by 1, something happens to y. So let's increase the value of x by 1. I move my pencil 1 unit to the right. We just changed the x value from 0. And if we move 1 spot to the right, now the x is lined up over here with 1. So increasing x by 1 means move 1 spot to the right. Now we're here. Now what happens to y when you increase x by 1? It decreases by 5. So let's show that with the pencil. Let's decrease y by 5. 1, 2, 3, 4, 5. And here is another dot. Through this dot and this dot, we can draw a straight line. And it's this line that is the visual representation of this math equation. Now in day 2, problem 2, it says, the table shows how much money Ava has saved. Assume the relationship between the two quantities is linear. Find and interpret the rate of change and the initial value. When we look in this table, I see that the first column is showing the number of months that Ava has been saving money. The second column is showing how much money she's saved. For instance, after 3 months of saving, Ava has saved $110. After 4 months of saving, Ava has saved $130, and so on. Okay. The first thing we're asked is, what's the rate of change? That is, every time the months change or increase, by how much is her money changing? Or how fast is her money changing? Okay. We want to find the rate of change. We want to find how is the value of y changing when the value of x changes. Okay. And we can do that by looking at the rows of the chart. We can look at any rows we want to, but as an example, we might look at the first and second rows of the chart. From 3 to 4, the value of x has increased by 1. 1 month has gone by. Now, in that 1 month, what happens to the value of y? It changes from 110 to 130. So it has increased by $20. And we can write these two changes as a rate, what rate of change is. Okay, so rate of change, it has increased $20 in 1 month of time. And so you write that like a fraction or a ratio, $20 compared to 1 month. Or another way to write this is $20 per month. Now the other thing we're asked is, what's the initial value? How much money did Ava have initially, or to start with, before she started saving? Okay? That's asking us, what's the value of Y? How much money does she have when the value of X is 0, when no time has gone by at all? But unfortunately, the table doesn't begin with a row that has a 0. If it did, whatever the number over for Y is would be the initial value. But it doesn't start there. It starts in the 3rd month. But we can certainly work backwards in the table to find out how much money would she have had in the 0th month. Okay? So we want to work backwards from the 3rd month to find how much did she have after 2 months, and then how much did she have after 1 month, and then how much did she have when X was 0, when she first started saving. Okay? And we can work backwards by using the fact that the rate of change was $20 per month. Okay? So when she's been saving for 3 months, right, the first row that we have information about, how much money had she saved? $110. Let's work backwards from there. How much money did she have saved after 2 months of saving? So if the rate of change is $20 per month, that $110 represents an increase of 20 over what she had a month ago. So how much did she have a month ago? 110 subtract 20 is $90. Let's work backwards again. How much did she have after only 1 month of saving? So $90 subtract 20 is $70. One more time. How much did she have when the number of months of saving is 0, meaning when she started, when she hadn't saved any extra money at all? So 70 subtract 20 is $50. So we have discovered that initially she had $50, and then every month that went by she kept adding $20 to that. Right? In the first month she was up to $70. After 2 months she was up to $90. After 3 months she's up to $110, and so on, as shown in the table.